So now we're going to talk about simplifying radicals. When we simplify radicals, square roots is the inverse of a square. So when we talk about what a radical is, the radical is the symbol for the square root. And what's inside, the value that's inside, is called the radicand. So the square root symbol is called a radical. So when we're simplifying radicals, that's what we're talking about. So to simplify radicals, we're going to use this product property of radicals. And what this product property states is if you have a number under the radical, you can break it out into factors, leaving them both under the radical, and it still means the same thing. So when we talk about simplifying a radical, what you're going to do is you're going to find a perfect square factor, and you want it to be the highest perfect square factor, and you're going to find the factor that's going to be left under. If what's under the radical is not a perfect square and doesn't come out as a whole number, when you're asked to simplify a radical, you're going to have to simplify a piece, and that piece is going to be the highest perfect square factor. So now when we talk about perfect squares, we can come up with a list easily by doing it in numerical order. Meaning, when we're looking for perfect squares are a number multiplied to itself. And what you get from that is a perfect square. So if I were to do the list of perfect squares, I would do it in numerical order, and I get 1, 4, 9, 16, 25, 36, 49, and so on. And where this list is coming from is 1 times 1 is 1. 2 times 2 is 4, or 3 squared, which is 3 times 3 is 9. 4 times 4 is 16. So I'm just mentally doing the squaring in numerical order, so I have my list of perfect squares. Now, if we had a perfect square under the radical, it would simplify to a whole number. If we do not, we're going to have to simplify the radical. Now, I kind of want to take a step back so you understand when you simplify a radical, it has to be in simplest form. Very similar to reducing a fraction. So this is just a little side note. If you have to reduce a fraction, and this is going back, when you reduce a fraction, it always has to be in simplest form. So if I take 8 over 25 and reduce it to 4 over 12, it's not in simplest form, therefore it's not correct. I would have to keep on reducing in order to have it in simplest form. So this is similar to simplifying fractions, that if you simplify a radical, you have to have it in simplest radical form. So let's do an example. So here's an example where I have the square root of 72 and I'm asked to simplify the radical. Well, to simplify the radical, the first thing I'm checking is what's under the radical a perfect square. So I look at my list here and I have 4, 9, 16. And again, I told you how it was created. I look and I see is 72 in the list, and it's not. So 72 is not a perfect square. So I need to take out the perfect square factor and find out what factor multiplied to it is going to be the leftover. And I like to start high with my perfect squares because I need to simplify it in simplest radical form. So I need to pull out the highest perfect square factor. So when I go down the list, I'm starting with the highest one. And I'm going to start with, when I look at it, I know that 49 is not going to divide into 72. So I'm looking at the next one, which is 36. So 36 divides into 72, so I can break it out into those factors where I have 36, which is my perfect square factor, and the factor 2, which is my leftover. Now all I did here was I took 72 and I broke it out into factors. 36 times 2 equals 72. But now I can simplify a piece of this radical. I can simplify the perfect square piece. So the square root of 36 will come out as a whole number 6, and I will just attach it to the leftover factor square root of 2. So this is what a simplified radical looks like. So the square root of 72 would simplify to 6 radical 2. Now I want to show you the same exact example, but say I was looking at this and I thought, well, 9 divides into it and 9's a perfect square. And I chose to simplify it using the square root of 9 times the square root of 8. 9 times 8 is 72. The 9 is a perfect square and it's going to simplify. And I simplify the 9 and I end up getting 3 radical 8. But what I want you to notice here is that my leftover piece, that radical 8, has a perfect square in it. Therefore, I did not simplify it completely. So if I don't simplify it completely, it's going to be wrong. So I'm going to need to also continue to simplify. So I take that radical 8. That radical 8 has a perfect square of 4 in it and my leftover of 2. And then I would simplify the 4, the square root of 4, and it would become the square root of 2. And then I multiply that 3 to that 2 that's on the outside, and you see we get the same answer, 6 radical 2. This would be in simplest radical form. So remember to look at your leftover radical and see if there's any perfect square factors in it. If there is, then you did not factor out the highest perfect square factor. So be careful when you're simplifying radicals. Pause and try. So in this case, we see that our perfect square factor is 4, my leftover is 3, and I simplify the perfect square piece and I end up getting 2 radical 3. So be careful here because again, you might think, well, 6 times 2 equals 12, so I can break it out into factors of 6 and 2, but neither one are perfect squares, therefore it won't simplify. So that won't work. So you always have to think of what is the highest perfect square factor and factor that out so you can simplify a piece of the radical. Pause and try. So my highest perfect square factor is 16. My leftover is 2. I simplify the square root of 16 and I get 4 root 2. So you don't keep on simplifying. Once it's simplified, you're done.